What if we could model a computer program on the structure of a human brain? Would that program be more effective at solving problems than a traditional program? Could it solve problems that traditional programs are incapable of solving? This was the idea behind artificial neural networks. Hello, my name is Matthew Meyer, and today I will be talking about neural networks, specifically the wine to vineyard neural network. Neural networks are an approach to computing and problem solving that is based on the structure of the human brain. Instead of using the straight line approach of traditional computing, neural networks use layers of interconnected nodes to solve problems. These nodes, or neurons, are broken up into three major groups: input nodes, hidden nodes, and output nodes. Input nodes take the input data from the user and perform basic computations and begin weighting them. They then send these to the hidden nodes. The hidden nodes perform additional computation, additional weighting, send it on to more hidden nodes. There can be dozens to hundreds of layers of these nodes with hundreds to millions of different nodes in between. Finally, we have the output nodes. The hidden nodes send the data, weighted and computed, to the output nodes. The output nodes then perform the final computation, the final weighting, and then output the result. The user cannot see each node and how it affects the criteria. The computations and weighting all occurs behind the scenes by the neural network. The neural network selects the weights and computations it uses based upon how it was trained. Before a neural network can be solved a problem, it must first be trained how to solve it. This is accomplished by providing the neural network with test data, problem data that it already has an answer. The neural network takes the data, attempts to solve it, and then compares the solution it got with the solution provided by the user. It then makes adjustments to its computation and weighting formula to better get the user provided answer. These tests are iterated dozens to hundreds of times until the neural network can solve the problem. After enough test iterations, the neural network will be able to solve the problem accurately every time. One example of a neural network is the wine to vineyard neural network. The wine to vineyard neural network was created to solve a problem. How do we determine if a certain bottle of wine actually came from the vineyard it is labeled with? In order to determine this, researchers at Adana Science and Technology University got 178 bottles of wine directly from 3 different vineyards. They then measured 13 different attributes of the wine for each bottle and compiled this into test data. These attributes were varied, included things like the ash content of the wine, the ash alkalinity, the hue, the color intensity, and the magnesium content of the wine. They then tested the neural network with this data until it could accurately determine from which of the 3 vineyards the bottle came from. This neural network could then be used with other bottles to determine if that bottle came from one of the 3 vineyards that they had tested. Neural networks have several advantages over traditional computing methods. First, neural networks can solve several kinds of problems that traditional programs have difficulty with. One kind of problem that neural networks are very good at solving is pattern recognition. The wine to vineyard neural network is a good example of this. The neural network discovered that certain levels of ash content, ash alkalinity, and magnesium content, and other factors were common amongst a specific winery's wines, and was then able to determine if a bottle it was provided which matched the pattern that it had come up with. Neural networking is also capable of identifying images, something other programs are not very good at. By presenting a neural network with millions of images of cars, that neural network will then become capable of identifying a picture of a car if you give it to one. Neural networks are also useful for solving complex problems where there are too many variables to create a mathematical model. In these cases, training a neural network with that data can be more effective at solving a problem than coming up with a complex mathematical formula. In conclusion, neural networks are a method of computing that is structured on the human brain. Using a node-based computing method and training from the user, these programs can solve complex problems. As computing power increases, the limit of this method of computing will only get higher. Thank you.